In this video, we'll look at a system of 3 equations and 3 unknowns. Our question is, which values of A, B, and C satisfy these 3 equations? And we have 3 equations, each with A, B, and C in them. And we can solve using any combination of the substitution and elimination methods. Adding the first 2 equations will help us eliminate B. If you look at equation 1 and equation 2, you can see that we have B and negative B. So this gives us the idea to add those 2 equations. When we add those 2 equations, we get 1 equals 2A plus 2C. So that's our first new equation. Then adding negative 3 times equation 2 to equation 3 will help us eliminate B. Notice in both cases we're eliminating B. And how did we come up with that? Equation 3 has negative B, and equation 2 has just negative B. So when we multiply equation 2 by negative 3, we get 12, and then here we get a positive 3b. So the 3b and the negative 3b will cancel. Then we add it all up and simplify, and we get 7 equals 3a minus c. That's our second new equation. So now we have 2 new equations, and they have 2 variables, so we can continue to solve. If we add our first new equation and twice the second equation, then the 2c and the minus 2c will cancel out, and we'll solve and get a equals 15 over 8. When we plug that back in to one of our equations, we get c equals negative 11 over 8. And then finally, we need to figure out what b is. So we can go back to one of our original equations. Any of them will do. This one has a plus b plus c, so it's simple to work with. And when we add our fractions, we get b equals 9/2. So we have our 3 unknown variables solved. Let's check. If we plug each of them into our original equations, 1, 2, and 3, 15/8 for A, 9/2 for B, and negative 11/8 for C, and we add up our fractions, we get 5 equals 40 over 8, that checks. Negative 4 equals negative 32 over 8, that checks. And 2 equals 16 over 8, that checks. So the solution to our system is A equals 15 over 8, B equals 9 over 2, and C equals negative 11 over 8.